Hi guys, the purpose of this video is to re-record a part of page 14 of your Unit 9 classwork packet. I must have been working off a different version of the packet when I made this video. My original one unfortunately is locked in my desk drawer back at school and I can't get to it. So thank you very much to the few of you who brought that to my attention. So I'm just going to be re-recording examples for the law of sines, numbers 9 and 10. Once again, this is the Unit 9 classwork packet. We're on page 14 and we're looking at numbers 9 and 10. Okay? So number 9, all right, number 9 up here for you looks something like this. All right, x at 77 degrees, 14, and 9. So as a reminder, what does the law of sines say? The law of sines says that if you have an angle side pair within any kind of triangle, whether it's acute, obtuse, or right, you can find unknown sides or unknown angles by simply using ratios. So step one, we're going to start by writing sine A over A equals sine B over B. Now let's check. Do I have an angle side pair? Or in this case, do I have two angle side pairs? I actually do. 77 and 14 and x and 9. So let me actually fill that in. So I'm going to say sine x over 9 equals sine 77 over 14. My question to you is, how do I get the sine x by itself? How do I get rid of a divided 9? Well, I would multiply both sides by 9. And so I get this. So sine x equals 9 sine 77 over 14. Okay, so far so good. Let's get out our handy dandy calculator so we can figure out a decimal for that, all right? So I'm going to put in 77, hit the sine key, times 9, over 14. So that's going to give me some long decimal that looks something like this, okay? 0.6263a, blah, blah, blah. But then if I want to find an angle instead of a side, I'm not going to use regular trigonometry. Instead, I'm going to use inverse trig. So all I'm going to do, everybody watch, I'm going to hit the big green button, and I'm going to hit the sine key. And lo and behold, I get 38.8 as my value for x. All right. Once again, I apologize if I did the wrong problems in the original video. That was my bad, and oops, nobody's perfect, right? All right, the last one we're going to take a look at for law of sines is the, I guess, the number 10 on the same page. So excuse me while I get my eraser, which is really just a rag, all right, for obvious reasons. Oops. Oh my gosh, I think my board's going to fall off. Oh, let's hope it holds for the next 5 minutes. All right, and last but not least, let's take a look at number 10 on that same page. Once again, we are in Mr. Klinsky's virtual classroom. Unit 9 classwork packet, page 14, question number 10. All right. So let's show a triangle. I got x, 31, 126, and 15. All right. So once again, law of sines is very nice when we have angle side pairs. When I say an angle side pair, I mean an angle that's across from a side, an angle that's across from a side, okay? So in this case, I'm going to write sine 126 over 31 equals sine x over 15. Okay, sorry that that's so small. That's my bad. How do I get that sine x by itself? How do I get rid of a divided 15? What's the opposite of division? Multiplication. So I get 15 sine 126 over 31 equals sine x. So let's get our calculator and let's actually put that in. How am I going to do this? I'm going to type in 126 first, then hit the sine key, then multiply by 15, and then divide by 31. And I get this long random decimal. Can you guys see that? Like 0.39-ish. So then, because I'm looking for the angle as opposed to a side, I'm not going to use regular trig. I'm going to use inverse trigonometry instead. So I'm going to hit the big green button, and I'm going to hit the sine key, and let's see what we get. I get around 23.0, all right? 23.0. So once again, these are exactly the same type of questions as what I recorded in the other video, just with the right numbers. All right, I apologize for any confusion. I hope this clarifies, and thank you again to those of you who brought that to my attention. All right.